Dear students, see last time we started revision of lesson number 3 and 4, that is kinematics. Today we will take some more stuff. Okay. Now let us say, see a particle starting from rest moves with the acceleration of a. Okay. See the distance covered is s. Then it moves with a constant velocity for some time, and finally see the retarded, okay, or a deceleration, and comes to rest. Okay, during that, let us say this is D1, D2 and D3. See the total distance covered is 5x. Okay, we have to find out the relation between s and 2. See total distance is 5s. Now see we try to plot the graph of this. See first it is accelerated motion, then with a constant velocity, then retarded motion. See this is a part 1, part 2 and part 3. See the total distance is 5s. We also know that the area of the velocity diagram is the displacement. Now first it moves with a constant acceleration and cover distance s. So part, let us say, total journey we divide into 3 parts. First is AB part. First part is AB. Distance covered is d square minus. Okay? Distance given is s. Velocity is v. Initially it is starting from rest, and the acceleration is f. So v square is equal to 2fs. V is okay? Okay, now this s is v square upon 2f. S is v square upon 2f. Now BC part moves with a constant velocity. So the distance covered is, this is our d1 is s, f, sorry, is constant velocity into time. Now what is the velocity here at v that we have obtained? Root 2 fs, and time is 3. Okay, then in CD part, C it moves with the retardation equal to f by 2. So what is the distance covered? P3 will be why? The question says the retardation is f by 2. So this will come out to be 2 into v square upon 2. See this negative sign will cancel. Now see what is the value of v square upon 2f, that is s. So this d3 has become 2s. Now our total distance is given 5s. That is s, d2 we don't know. Okay, now this will make 3s. Okay, now sorry, this d2 is 2s. Okay, now we have to obtain the relation between s and d. Now this 2s distance is a distance covered during the second part, that is our d2. This is also d2 and this is also d2. So we can compare. See this root 2 fs into d is 2s. See if I take square on both sides, 2fs t square is 4s square. Okay? Okay? Now we can solve. See one of the 2 2s are 4. S also will cancel. So we can say ft square is 2s. S is equal to 1 by 2 ft square. Okay? So this is the relation between f and s. Okay? Now this is how we can solve the question. Now, see, there is a similar question, okay, in which the total distance is given as 13s. Okay, total distance is given as 13s. Let us say it moves with the acceleration of f, then it moves with the constant velocity, then it moves with the retardation of f by 2. See, let us say the total distance is x. Okay. In this also we have to derive the relation between s and t. See, this you can try yourself. Okay, this you can try yourself. So this is an important question that we should solve. Okay, now we take some more question. Now, see, this is related to one-dimensional motion. Now, see, the particle moves on circular path. Okay, start from A. See, this is pi by 3 angle. Radius is r. Okay. Now, see, AB part. It moves with the speed s. Okay, then 90 degree. BC part moves with the speed 2s. Okay, and the remaining part. Okay, remaining part. Okay, CD or CA. Okay, now it moves with the 3s. Okay, it covers distance is 3s. Now, see, we have to calculate the average. Okay, now see, here we have to calculate the average speed is total distance upon total time. Total distance is total time. Now see, first part, AB part, length of the arc is s. Okay, now see, length of the arc will be s into pi by 3. Okay, now let us say time is t1. Let us say time is t1. So, okay, now this is s, 2s and 3s are the speed. Sorry. Okay, s, 2s and 3s are the speed. See, we have to calculate the average speed. Okay, now see, AB part speed is s. Okay, speed is s. Time we have to calculate. What is the distance covered? AB part length will be L is equal to r theta, r into pi by 3. Okay, now let us say the time is t1. Okay, so speed is equal to distance upon time. Okay, distance is r into pi by 3 upon time is t1. So t1 is pi r upon 3s. Okay, now BC part. Here speed is s, speed is 2s. So here length of the arc will be, distance will be equal to r into pi by 2. Okay. Now let us say the time is t2. Okay, time is 2. So again we use the formula, speed is equal to, distance is r into pi by 2. T2. Okay, now see, this angle is not given. Okay, the total angle is 360. It is 2 pi minus pi by 2 plus pi by 3. 6, 3 pi plus Okay. Now see 360 degree is 2 pi radian. From that we have to subtract. So this will be 6 into 2, 12 pi minus 5 pi by 6. There is 7. Now see the speed is 3s. Length of the arc will be 7 pi by 6 upon times t3. Okay. So t3 will be r into 7 pi upon 3s into 6. 18s. So first time we obtain is t1 is pi r by 3s, second is pi r by 4s, and time t3 is 7 pi r by 18s. Now speed is total distance upon total time. See what is the total distance, circumference of the circle? Okay. So the distance covered will be 2 pi r. Time we have to add t is equal to t1 plus t2 plus t3. That is pi r by 3s, pi r by 4s plus pi r by 7 pi r by 18s. Now see here, we have to take LCM. Okay. See 3, 4 and 18. Okay. Now what is our LCM? 2 to the 4th is 12, 3 is 36. Okay. Now pi r is common here. 36 upon 3 is 12. 36 upon 4 will be 9. 36 upon 18 will be 2. Okay. Again 36 upon 3 is 12. 36 upon 4 is 9. 36 by 18 is 2. Okay. This will be 12 plus 9, 21 plus 2, 23. Pi r by 26. Yes. Okay. Now this is the total time. Okay. This is the total time. Okay. Average speed is total distance upon total time. Total distance is 2 pi r. Okay. 23 pi r by 36s. That is 2 pi r upon. Okay. Now see this r will get, pi r will get cancelled. Okay. Pi and r will get cancelled. Okay. So 72s upon 23. Okay. What I want to simply show that see the average speed is total distance upon total time. Okay. That we have calculated here. Now see the next question. Now we take some question regarding the vectors. Now see the question is like this: 3 upon. Okay, we start with we take some basic question. Okay, related to unit vector. Okay, now let us see how to find out the unit vector of a given vector. Now let us say A is equal to 3i plus 4j. Okay, how to find out the unit vector of this? See, books have said some basic things, but important thing many times we have to find out that is not given, that we should discuss here. This how do we get a unit vector of this? Okay, see a vector upon its magnitude. Okay, dividing the vector by its magnitude we get a unit vector. So what is the magnitude of the vector? A is that we obtain is 5. Okay. 3i plus 4j upon 5. Okay, so this will be the unit vector of A. 3 by 5 I caret plus 4 upon 5. Okay, why? Because as the name suggests, because it is a unit vector. So if I find out that its value, we should get what? 9 upon 25 plus 16 upon 25. Okay, so this is how we can find out the unit vector of the given vector. Now, see, we studied about scalar product and vector product also. Okay, we studied about the scalar product and vector product also. Suppose we have to find out, let us say A is given as A P I minus 2j plus 3. Okay, find out unit vector which is perpendicular A and B. Now we studied in the properties of vector product. Let us say A vector and a B vector is here given. See, if I find out the unit vector, the cross product. Okay, then unit vector of this vector A cross B will be perpendicular to plane formed by vector A as well as B. So suppose we have to find out the unit vector which is perpendicular to both of the vector. Then what we should do? First, we should find out the vector product. So now we find out vector product of A cross A and B, I, J and K. So what are the coefficients? 2, 3 and minus 1. 1 minus 2 and. Now I cross A cross B we have to find out. See, there is a right diagonal. These are 9 minus this will become positive minus 2 minus j caret 8 2 3 are 6 minus plus 8 okay 2 2 are minus 4 and minus 3. So that is 7i minus 7j plus minus 7. Okay, now this is our A cross B. See, if I find out the unit vector of this, how to find out the unit vector of this? First we have to calculate the magnitude. So if I take 7 common also, then it's also okay. 7 is common. I minus j minus k. Okay, I minus j minus k. See, what is the magnitude of I minus j minus k? 1 square plus minus 1 square plus minus 1 square. That is root 3. So, how to get a unit vector of this vector I minus j minus k? See, we have to divide by the magnitude. That is I minus j minus k upon root 3. See, that is nothing but our n caret. N caret is a unit vector which is perpendicular to both of the vector. See, given as A and B. N caret is a unit vector which is perpendicular to the given vector A and B. So, see, that is property of the unit vector. That is the property of the unit vector. Now, see, next question that we take related to projectile motion. Now, see, the projectile motion is a constant horizontal velocity, and constant vertical acceleration. Now we take some question. Okay. Now suppose it is given r is equal to 4h. See, the range of the projectile is given as 4 times height. What will be the angle of projection? Now what is the formula of the range? V0 square sin 2 theta upon h is nothing but our maximum height. V0 square sin square theta upon. Yeah. So if I substitute this value, V0 square sin 2 theta upon V0 square sin Now we have to simplify. Next we have to simplify. So this V0 will vanish. G also. Okay. Now sin 2 theta is 2 sin theta cos theta. Okay. That is 2 sin square theta. This we can write x square. We can write x into x. So it will be 2 sin theta into sin. See, one of the sin theta will cancel, 2 will be cancelled. So sin theta is equal to cos theta. That is tan theta is equal to theta is 45 or pi by 4. Okay? So when angle of projection is pi by 4, okay? See the range it will be equal to 4 times. Okay? Range will be equal to 4 times. Okay? Now next we take the question which is related to stopping distance. Okay? Next is the question related to stopping distance. See, you can also send your queries. You can send me the question which are related to lesson number 3 and 4. See, I will try my best to solve it. See, next is the question related to stopping distance. Now let us say when car is traveling at speed of 40 km per hour and brakes are applied, see the stopping distance is 6 meters. Okay, it stops in covering 6 meters. Okay, now see if it was to be traveling at a speed of 80 km per hour, what would have been the stopping distance? Okay, now you know the stopping distance is proportional to, see again recall formula D is equal to V square minus V0 square upon 2a. The final velocity is 0. Now brakes are applied, so we have a retarded motion. So ds is the stopping distance. So what we can see, stopping distance is proportional to V0 square. See, we consider it is a uniformly retarded motion. Now here when the car is traveling with the speed of 40 km per hour, stopping distance is 6 meters. If the stopping distance is car initial velocity is 80 km per hour, what will be the stopping distance? So we know the formula D is equal to V square. So V2 upon D1. Now that is 80 square upon D1 given as 6 meter. Okay, so sorry, D2 is 6 meter. 8 upon 4 is 2 square. Okay, so we will remember, see the stopping distance is proportional to square of the velocity. Okay, stopping distance is proportional to square of the velocity. Yes. Now, next question. See, we take related to the relative velocity. Now, see the velocity of a swimmer is 4 km per. Okay. Now let us say it is given as 4 km/h. See. Now it has to cross a river. Okay. It has to cross a river which is 8 km. Why? Okay, now see we are not given the flow of the river. Okay, of the flow of the velocity of the swimmer is 4 km per hour. Width of the river is also width is given as is 8 km. Okay, see with what angle he should swim. Okay, with what angle he should swim so it moves perpendicular to the river. Why? Because see the flow of the river, see his motion will be diverted. Okay, now see this is the width of the river, 8 km. Now see the swimmer speed is 4 km per hour. Okay, now it should not be like this. Let us say the swimmer is, let us say, 12 km. Okay, now with what angle he should swim? So it will cross the river perpendicular. Okay, this is a hypothetical sum, so that's why we can have some variation in the exam. Okay, now let us say, see the flow of the river is like this. So if the swimmer just start in the vertical direction, because of the flow, its motion will be diverted. But we can say he is smart, so he swim with some angle with the vertical. Now let us say, for consideration, this is our y-axis and this is our x-axis. This is using. So we can write, let swimmer swims at angle theta with water. Okay, now this is the flow, this is the width of the river is 8 km. So how do we get the angle? Okay, now we are given adjacent side and this is the hypotenuse. Okay, in a right angle triangle, cos theta will be adjacent upon hypotenuse, 8 upon 12, 4 by 2 and 4 by 3. Cos theta is 2 by 3. Now see what is the component of the velocity? What will be the component of velocity? See, this will be v cos theta, 12 cos theta, and this will be 12 sin theta. Okay, this will be 12 sin theta by the definition of component of vector. Now see our cos theta. Okay, is 2 by 3. So what will be this side? Will be root 3 square minus 2 square, 9 minus 4, root 5. Okay, now see the component of velocity will be responsible in the horizontal dimension. Our horizontal direction is 12 sin theta. Okay, so the component of velocity in horizontal direction is 12 sin theta. Okay, and in the direction perpendicular direction 12 cos theta. Now see the distance covered is 8 km. Okay, now v is equal to d upon t. Okay, 12 cos theta. See 12 cos theta is the component. Distance is 8 km times t. Now cos theta value is 2 by 3. Okay, is equal to 8 upon t. Okay, so now we can solve. Okay, so 12 12 into 2 is 24. By 3 is 8 upon 3. So T 24T is 24. So T will be 1 hour. Okay? Okay? So this is an hypothetical sum, but I want to just explain that how to solve. See, width of the river was given as 12 km. He tried to swim right angle, barabar, okay? But he has to swim with some angle so as it moves perpendicular. Why? See, the parallelogram law you can easily solve. See, this is a component. This is a component. So the resultant velocity will be like this. So 12 cos theta will be the component in vertical direction. Okay, the distance covered in vertical direction is 8 km. Okay, so this is how we can solve. Now this is a problem question regarding to the river flow. Okay, so now here also what we consider is a two-dimensional motion. Now, let us say a question regarding the vector. Now, P is a particle whose component is x and y, angle is theta. Okay, so we have to find out component of vector which is perpendicular to this. See, we have to find out the unit vector n caret. Okay. N caret which is perpendicular to the given vector. So now this is our vector r. Now we see r is equal to xi plus yj. This is x component and y. Okay. Now what is x? See, cos theta is x upon r. So x is equal to r cos theta. Okay. Cos theta is x upon r. Okay. And sin theta is y. So y is equal to r sin theta. See, our position vector r is equal to xi plus yj, r cos theta I caret plus r sin theta. Now suppose we have to find out a unit vector, okay, which is perpendicular to this. So first we have to rotate by